You've probably seen it on a label for workout gear or maybe even your bed sheets, a little tag that says antimicrobial or fights odor. It's this tech that's kind of quietly everywhere in our lives. So today, we're going to pull back that curtain and really dig into the science, into this invisible war that's happening on the clothes you're wearing right now. So let's start with something we all know. That moment you open a gym bag you forgot about and wow, that smell hits you like a brick wall. But what's really going on there? I mean, it can't just be sweat, right? Nope. It's something way, way smaller and a lot more active. That's right. Every single thread of your clothing is basically a microscopic battlefield. And this isn't just about stinking up the laundry hamper. We're talking about things like stains, your clothes wearing out faster, and just general hygiene. So let's break down this invisible war, starting with the battlefield itself. Okay, so what is it about our clothes that makes them such prime real estate for this, well, this invisible invasion? As it turns out, textiles are pretty much a five-star resort for microbes, giving them everything they need to not just survive, but to absolutely thrive. The main troublemakers here are bacteria and fungi. These little guys are everywhere, all the time. But when they land on our clothes, they find this perfect little ecosystem. You've got warmth from our body, you've got moisture from our sweat or just the air, and boom, it's party time. And that party leads to all sorts of stuff we really don't want. And when I say they multiply, I mean they multiply. Get this. Under the right conditions, a single bacterial cell can explode into over 1 million cells in just 7 hours. That is an insane growth rate happening right there on the sleeve of your favorite t-shirt. And here's what's really interesting. It doesn't matter if your shirt is natural or synthetic. They're both vulnerable, just for totally different reasons. Think of natural fibers like cotton. They're basically a free buffet. They're porous, they soak up water, and the microbes can literally eat them. Now, synthetics like polyester, they're not food, but their structure is amazing at trapping moisture and all that good stuff between the fibers, creating the perfect swampy nursery for bacteria to breed in. So what's the end result of this microbial free-for-all? Well, it's not great. You get that infamous gym bag odor, which is literally the byproduct of bacteria breaking down your sweat. Yuck. But you also get stains and discoloration. The fabric itself starts to break down and fall apart. Sometimes it even feels sticky or slimy. And in some cases, there's even a risk of spreading germs from one place to another. All right, so we've laid out the problem pretty clearly. How do we fight back? Well, this is where antimicrobial finishes come in. The industry has basically come up with two primary strategies, two different battle plans for taking on these unwanted microscopic squatters. So here they are, the two main approaches. On one side, you have controlled release. Think of this as the offensive strategy. It sends out agents to attack the microbes. On the other side, you have the bound agent. This is more of a defensive fortress that's built right onto the fabric, waiting for microbes to make a fatal mistake. Let's dig into that controlled release idea a little more. The best way to picture it is like a microscopic minefield laid out on your clothes. The finish slowly lets go of these little chemical agents, creating a kill zone that poisons any microbes that get too close. It works really well. But there's a catch. Just like a real minefield, it has a limited supply of ammo. Every time you wash it, some of that ammo gets used up or washed away, so it doesn't last forever. Now the bound agent mechanism, it's a whole different ballgame. Forget the minefield. This is more like a microscopic bed of nails. The antimicrobial agent is permanently bonded to the fabric. It doesn't go anywhere. It doesn't get used up. It just sits there, and when a microbe lands on it, pop. It physically punctures the cell membrane and destroys it on contact. So we've got the battle plans down. But what are the actual weapons? What are these agents? Well, the antimicrobial arsenal is huge, and we can pretty much split it into two main camps, the natural stuff and the synthetic stuff. You know, the natural world has some pretty amazing antimicrobial tricks up its sleeve. We're talking about things like chitosan, which, get this, comes from the shells of crabs and shrimp. Then there's sericin, which is a byproduct of silk. And of course, you've got all these potent extracts from plants like neem, tea tree, and aloe vera. The big selling point here is that they're often seen as biodegradable and non-toxic. And then you've got the synthetic heavy hitters. These are the powerful lab-engineered chemicals that often kill a really broad range of microbes. Silver, for instance, has been used for literally centuries to kill germs, and now we can make it into these tiny nanoparticles for textiles. Then you've got these powerful chemicals with long names, like quaternary ammonium compounds, or QACs, PHMB, and an agent you might have heard of before, triclosan. But And this is a really big but. That power can come with some serious baggage. Take triclosan. It works, no doubt, but there's a dark side. As this quote points out, when it gets out into the environment and is hit by sunlight, it can break down into compounds that are related to really toxic dioxins. And that right there introduces this huge, complex question. How do we balance being effective against microbes with the potential harm to our health and the environment? Okay, so now that we've got the science down, let's step out of the lab and look at where this stuff actually shows up in our daily lives. I think you're going to be surprised at just how common these finishes are, often in places you'd never even think to look. So yeah, the obvious ones are in our clothes, right? Athletic gear, socks, underwear, all to fight that odor. But they're also absolutely critical in things like shower curtains to stop mildew, or in medical settings on hospital gowns and bedding to prevent the spread of infection. It doesn't stop there. They're in industrial stuff like tents and tarps to keep them from rotting. This technology is, quite literally, woven into the fabric of our world. So if a company says their socks fight odor, how do they actually prove it? And what are the bigger, more critical questions that we should all be asking about a technology that's become this widespread? In our final section, we're going to look at exactly that, testing and the bigger picture. Okay, first there's a little bit of vocabulary we need to get straight, because it's super important. A finish can either be a biocide, which means it actively kills microbes, or it could be a biostat, which just means it keeps them from growing and multiplying. Now that might sound like a tiny difference, but legally it's a huge deal. Biocides, because they're designed to kill, are regulated way more strictly by governments. And to verify all these claims, the industry uses standardized tests. For example, one common test is the ATTC 147. It's pretty cool, actually. You basically put a piece of the treated fabric onto a petri dish covered in bacteria. If the finish is working, you'll see this clear ring form around the fabric where nothing can grow. That's your zone of inhibition. But if you need hard numbers, there are other tests, like the ATTC 100, that actually count the bacteria to give a quantitative result. And all this brings us to the most important questions of all. You know, the big ones. How long does this finish actually last? Is it still working after 50 washes? Is it safe to have against our skin all day, every day? When these chemicals wash down the drain, are they killing the good microbes that we need in our water treatment systems? And maybe the scariest question of all, by using these things everywhere, are we accidentally training bacteria to become stronger, to become resistant superbugs? And that really is the final heavy question we're left with, isn't it? In this big push for everything to be cleaner, fresher, and more hygienic, we've deployed this massive chemical arsenal into our lives. But as we keep fighting this invisible war, we have to ask ourselves, are we winning today's battle only to risk creating a much bigger, much scarier enemy for tomorrow?